everybody, and welcome back to Learning and Understanding Unreal Engine's Blueprint. In the first two episodes, we talked about the fundamentals of blueprints, and then we talked about how to get those blueprints to communicate with each other. We made this fancy little box where if we get close to it, we have a collision around us, and when that collision hits the other blueprint, it sends a generic message or an interface to the block and squares it up with the level. Boop. However, this raises a lot of questions like, what if we only want that to happen if only certain conditions are met? Like, what if we only wanted a door to open if it was unlocked or the player had the key? Well, luckily, with the use of variables, we can create certain conditions and then use logic to dictate whether or not the code continues to fire or change the path of the code. No ads, earlier content, ask me questions, and even get a Discord call with me to help with your game. These are all on my Patreon right now. This is the code for the current Magic Box setup. Here's the interface or the generic call, and here's where we set the rotation. Right now, the only thing we could do is change the number of the X, Y, and Z on this set world rotation, and that would change the way that it rotates, but it's still very static. We can't change it beyond that unless we go back into the blueprint and we change those numbers around even more. We also wouldn't be able to make it instance-based, and what I mean by that is just because you have one house or container that contains certain things, if you duplicate that house, they actually don't have to be in the exact same configuration. It just depends on how you code it. Let me give you a better example. To give you a better example, on the left-hand side, we're gonna go down to variables and I'm gonna click the plus. Today we're gonna be focused primarily on Booleans. Boolean is a fancy word for true or false. We are going to name this Boolean rotate with a question mark. And as you can see, there's not much I can really do with it. If I hit save and compile, you'll note that on the right-hand side in the details, I can now make it true or false. That's fine and all, but how do we get it to dictate what our code does? Well, the first thing we're gonna learn about today with the Boolean is the branch. This is gonna be something you use a ton in your blueprints. Now, there's multiple ways to get the branch. You can do the way that we're used to, which is just right click or pull out of something and just type in the word branch, or the more efficient, convenient way is just hold B for branch and click, and you'll get a branch node. I'm gonna plug this into the generic call or the interface that we have here, and you'll note that it requires a condition, and then we can have two different nodes fire depending on whether or not it's true or false. So let's go ahead and take our rotate variable, drag it out. Now we can either just let go and click on get and plug it in, or if you want to go a little bit faster, you can pull it out and drag it directly onto condition. It will automatically plug it in, and we can move it to a better spot. And now, if rotate is true, we have a pin for the code to go off in that direction. If it's false, we have another pin for the code to go off in that direction. Now note that you do not have to have these pins plugged in. For example, if we don't want anything to happen if rotate is false, then we just don't plug anything in here, and it simply will not fire. If it's false, the code stops. So if rotate is set to true, we will make it so it actually does the rotation that we programmed it to do if we get close. For right now, I'm gonna go ahead and click on rotate, and on the right-hand side, I'm gonna leave it false. And then I'm gonna hit save, and I'm gonna hit compile. We'll go back to our first-person map and hit play. So now, as you remember, we didn't plug anything into false. Now when I get close, you'll note that the box does not do what we were telling it to do. That is simply because it's a generic call. The generic call runs this function, it hits a branch, and it says rotate. Well, rotate's false. There's nothing plugged into false. The code goes no further. If we click on rotate and change it to true, and we hit save and compile, you'll note it'll do exactly what you expect. Now it will actually pass the branch and rotate as we would expect it to. However, you'll note that this is exactly the same on every version of this box. Watch what happens when I hit play. Because of how we have it coded currently, they will all act identical. They're all gonna turn, or if I change this to false, you'll note that they're all going to not turn. Well, that might not be what we want. We might want these to turn or not turn depending on certain conditions. And one way that we can make it to where each instance has its own true or false variable is to simply make it public. By opening this eyeball next to the rotate Boolean right down here, it makes it so it is instance editable and it is a public variable. What that means is it takes up, like, I'm talking an insignificant amount more of memory because it's simply exposing itself to other blueprints and things of that nature. Don't worry too much about that. But what you do want to focus on is now, whenever I click on one of these magic boxes, on the right-hand side, you'll see that there is now a default section under the details. And there's our variable. It says rotate ? Well, what if I make this true? If I click on another one, you'll note that these remain false. So if I was to hit play and get close to these, note that only the center one is going to rotate. By making them public, you're also making them instance editable, which basically means that each one can have a separate one depending on what you want to set as a default value. Now, that does not mean that a blueprint cannot have its own custom set of variables separate from another instance of the blueprint, which was a mouthful, but I'm just simply saying this is not the only way to have it so they have separate variables, but one that's very, very useful. For example, if this was a set of 3 doors in a level in different locations, and we only wanted one of them to be unlocked, maybe this is the tutorial door, we could lock the other 2, then whenever we approach, only the one opens, so that way we can guide the flow that the player is doing through the level. Let's look at another example of where Booleans are going to be extremely useful. If I hit play, you'll note that if I go through this middle section here, I've created a tutorial message that lets people know if you get close to boxes, they will rotate. So I get close to the box and then it rotated. However, if I re-enter, it's going to tell me the tutorial message once again. And if I were to keep entering, it's going to just keep appearing over and over and over. So we're going to do a brief exercise where we go into how we can make it so that tutorial message only appears once. If you look at the blueprint, I have a simple touch field, and then in the event graph, go ahead and ignore everything in the box for now. We have the event actor begin overlap. We make sure it's us. Then this part that you can ignore simply just adds the widget on screen, waits 5 seconds, then removes it. However, we need to create a variable that will make it so this only appears once. And, hint, we're going to use Booleans. So, what I'm going to do is I'm going to create a new variable and I'm going to call it activated. We'll go ahead and hit save and compile, and by default, Booleans are set to false. So I'm going to pull activated onto our graph. I'm going to disconnect this pin. I'm going to hold B and click to add a branch. And then only if activated isn't true, will we continue. If it has been activated, we don't want to continue. So how do we change activated to be true after this code runs? Well, pretty simple actually. What we'll do is at the end of our code, we'll simply go to activated, we'll pull it out, hit set, and make it so activated is true. Now I'll hit save and compile. So now what's going to happen is it'll check if it's us. We'll see if it's been activated before. If it hasn't, we will display the tutorial message. Then, whenever the tutorial message is gone, we set it that it has been activated and the box will no longer display the message. Let's go ahead and hit play. Let's touch our box, get close to boxes for them to rotate. We'll come through, we'll be like, look at that, boxes do rotate. But now when we exit, because we set that Boolean, it will no longer display on screen. The crazy thing about Booleans is they can be math-based as well. But let me show you what I mean. I'm just gonna name this number, and I'm going to make it an integer. I'm gonna save and compile so I can edit it. And I'm just gonna make it the number 5. If I pull out our number, which is currently set to 5, and I type in the greater than symbol, for example, you'll note that we're gonna check and see if number, or 5, is greater than 0. And you'll note that it outputs a Boolean. So if we had a branch here, is 5 greater than 0? If the answer is yes, then we know that the Boolean that it sends out will be true. If the answer is no, then the answer it will send out will be false. And we have all kinds of these. You've got greater than, you've got greater than equal, less than, less equal. You've got just straight up equal. Essentially what I'm saying is Booleans are very powerful when it comes to controlling the flow of your code. Or in this case, is their current health greater than or equal to their max health? If no, they can use the health kit. So that's all fine and dandy, kind of basic, but let's really get into the meat of this. Let's put together everything we've learned into one basic system. Let's make it so the cube only rotates if the player holds a key. That's going to require our blueprints to communicate and some basic logic using Booleans on whether or not the cube rotates. Well, we have our cube and we have our player. We know they're going to have to be able to communicate, so we know that we can do that with interfaces. So let's go ahead and right click. Let's go up to blueprints and create a new blueprint interface. I'm gonna call it interface underscore key check. I'm going to open that up and I'm gonna rename this function by clicking on the name and pressing F2. I'm just gonna call it key check function. Now I haven't talked about this yet, but you'll see it's pretty self-explanatory. We're going to require an input. So let's notice what happens when I hit the plus here. I'm gonna hit the plus and you'll note a couple things. One, on the node, you'll see that there is a new parameter. Right now it's currently a Boolean. And down here under inputs, we have, again, new parameter in Boolean. I'm gonna name this key ID, and I'm going to use the variable name. For now, don't worry too much about that. Then we are going to require an output. And don't worry, I will fully explain this. For the output, I'm going to name has key with a question mark, and I'm going to make it a Boolean. So what this interface is going to do is it's still going to do a generic call, but it's going to do a generic call with the intent of this function being ran. Basically, the door, or in this case the box, is going to make a call with a key ID. What it's going to say is, hey, do you have this key ID? Then they're going to return whether or not they have that key ID. Now you're probably wondering how they're going to do that because there's no logic here. Well, anytime you're requesting information via an interface, all of the logic is done within each individual blueprint. So we won't do the logic here. We just need the inputs and the outputs. Let's go ahead and hit save and compile. Now in the first person character, we are going to create a new variable. I'm just going to call this key ID, kind of like part of the interface, and it will also be a name. I'm going to go ahead and save and compile so we can alter its default value. I'm simply going to name it key02, and you'll see why in a moment, and hit save and compile. And then if you remember, within class settings, we can implement an interface. So we are going to implement the interface underscore key check. Once we've done that, I'll save and compile one more time, and you'll note that within our interfaces, we now have the key check function. If I double click on that, you'll note that now we have the same two nodes from the interface, except we can actually add logic. I can simply uncheck this, and you'll see that now I can add things between them. So for example, the input we needed was a key ID. So what we're gonna do is we're gonna match up and see if these key IDs are identical. So I'm going to type in equal, and I'm gonna plug both of these in. And there we go, we now have a Boolean. So I will then go from there straight to the return node. If the inputted key ID equals the key ID that the player has, then we will return true. If these aren't the same, we'll return false. So we'll hit save and compile. Now we'll head to the magic box. Currently, we're only checking to see whether or not we should rotate based on this one Boolean. So I'm gonna delete that out, and we're gonna move the rotation down. Because we created that interface, that generic call for us to be able to talk to other blueprints, now we can actually pull out here and type in key check. And of course we want the message. The target in this case is going to be the player character. And for the key ID, let's go ahead and create a new variable and just name it key ID. And for the name, I'm just gonna go ahead and make it public. So that way, each one of our boxes can have a different key ID required to open them up. I'll go ahead and plug that into this variable. And then we can put a branch afterwards, because remember, it's going to return the Boolean true or false as long as the key ID matches up on both. And then if it does, we'll rotate. So we'll hit save and compile. We head back to the 3D space, and you'll see now in our default value, the rotate is still there, but that is a little unnecessary. We're not gonna be using that. But we have a key ID. Remember how I set the player one to key 02? Let's set this to key 01 and hit play. You'll note that when we approach, it doesn't rotate. Why? Because we have a different key. We're specifically using key 2. So what if we change this to needing key 2? Well, when we hit play and go over, boom, look at that. Quick recap of what just happened. The player has a variable that is currently a name, and it's set to key 2. It's using an interface that basically just simply returns true or false based on the key ID that the request has. So for example, Magic Box 1, when it sends the request, has its own key ID variable. So it sends that request to the target, which is the player character. The player character sends back true or false. That's a Boolean. We have a branch. If it's true, we change the rotation. This episode was a little bit more complicated in certain places and a little bit more easy in certain places. Please let me know if you've gotten confused or if you're still going along and enjoying the ride. Please like, comment, and subscribe, and I'll see you in the next episode.